In this demo, we will demonstrate how the FedL Federated Learning component is deployed to the Marvel platform. So here you can see that we have some services already running, both for the server and the client sides of the component, but we will now go through creating these services and what are the offered options for these services. So to create a new service, we go here to the new service, and then we need to select what type of service are we creating. Here we have the audiovisual crowd counting model, federated learning clients and servers. So the server only has one option, it is for running in the cloud, while the client has multiple options. In addition to running only on the cloud, we can also run it on various fog machines. So these templates are the same, it's just the difference is just where the service is running. So we can, for example, try creating a client running at Fort Fog 2 machine, and when we click create, we are presented with this page where we can set up some parameters for this client service. So we can select the name of the service, we can choose the version of the component or the Docker image that is going to be used for this service. We need to tell the client service where the server, the federated learning server, will be. So this is the name that we will later give to the federated learning server component. And there are some specific parameters for this specific client. So for example, disco path is the path to the training data set that we want to use for training, or where the data will be loaded to be used for federated learning. We have some other parameters, for example, use GPUs, whether to use GPU acceleration in training, whether the service needs to have graceful exits. This is useful for debugging, so we can disable the graceful exit and container will hang until we extract the logs or some other useful information from it. And finally, we have client ID. This is important for the federated learning framework, so we can have unique identifiers for all the different clients, and we can also set the number of epochs that we are going to run the training on this specific client. So that's the client side. On the server side, it's a little bit simpler. So if I want to create a federated learning or FedL server, I go to create a new service, select the audiovisual crowd counting federated learning server, click on create, and here we can also set up some parameters. The name and the version are similar to what we had before. Name is very important because as parts of Kubernetes cluster, the networking is realized through names of services, so this name has to be the same name that the clients will have for their server, so it's the server that they report to. We can also pass some arguments to the server Python script. For example, we can choose a strategy. By default, we are using our own non-uniform sampling strategy, but we can also pass, for example, to use the federated averaging strategy. We also have the option to use model repository component. So if this is set up to be used or set to enabled, we will then store the trained models to the model repository and retrieve the starting point model when the federated learning process is starting. And again, we have the graceful exit, which is just useful for debugging. Now I already have some components here set up, or services. We have one server for audiovisual crowd counting model and 2 clients, and we can monitor these components and how they work through the KubeBox service, which is used to monitor the Kubernetes cluster. So here we can see the logs for the server, and we have the 2 clients here on the top. We can see that our non-uniform sampling strategy is providing some debug output, whether some clients should send their updates or should they be skipped. So that's all that can be seen here in the Federated Learning server. And we can also check the logs of the clients and see how the training is going. So here we can have any specific information for the client side of the federated learning process. Another important thing, just to mention at the end, is that because these components are available as services through the Marvel dashboard, they can be automatically started, and the federated learning process will then start. And this is important because other components, when the data arrives at various points in the architecture, will need to start these components and start the federated learning process.